Well, ladies and gentlemen, it's with great anticipation and pride that we await this occasion every year. And so it's my distinct pleasure that I welcome you to this Virginia Tech tradition, the Vecellio Distinguished Lecture. I'm Sam Easterling, and I have the honor of serving as the head of the VIA Department of Civil and Environmental Engineering. Before we begin, you all came in this way, but a couple logistics in case something would happen. We need to get out in a hurry. 2 exits at the back, 2 exits at the front. Just be aware of those. And at the end of the lecture, I invite you to join us out in the lobby for a reception just outside this magnificent Quillen Auditorium. I'd like to begin these proceedings by thanking the Vecellio family, whose endowment has made this lecture series possible. Thank you for all you do to support us, the students, and our program. Mr. Michael Vecellio, sitting down in front, president of the Vecellio and Grogan firm, is here representing the family. And Michael, I also want to say it's great that you've really opened your door, so to speak, and we're going to have students and faculty tours on this I-81 bridge project over the New River in the coming year. So really looking forward to that. So thank you. Also, I'd like to recognize Dr. Mike Forster, sitting down in front, who's the 2010 Vecellio lecturer, and his wife Meryl is with us. And also like to recognize my colleague. I think I saw him come in, but where is Brian? Dr. Brian Kleiner, who serves as the director of MLSOC here on campus. So Brian, welcome as well. And finally, I'd like to acknowledge the great work of Dr. Chema de la Garza in overseeing all aspects of the planning and execution of the distinguished lecture. If you've been coming a while, you'll know this is the first time in 14 years that Chema's not standing here. And despite jokes that those of us that know him might tell, he lost his voice 2 days ago. And so he's not able to really stand up here and do this. And I know Chema would also want to acknowledge the significant assistance he received from Ms. Rachel Hill. And I think Rachel is hiding in the back. So thank you both. Please join me in thanking both of them. So a very important component of the Vecellio endowment is the funding of scholarships and fellowships. And earlier this summer, through a very competitive process, 8 Vecellio undergraduate scholars and 1 graduate fellow, Vecellio graduate fellow, were selected. I'd like to introduce them to you now. And as I call their name, they're going to come up front and kind of hang out while I call everyone's name. So the first is Will Cole, whose hometown is Marshfield, Massachusetts. And you see on the screen, I'm going to say a bit about each one of them, but not a lot. His hobbies are guitar, sports. He's an outdoor enthusiast, likes traveling. That's probably a good thing, as his career is going to involve the commissioning in the United States Army, and then further pursuing higher education in civil engineering. Mr. Lewis Hatcher from Springfield, Virginia. His hobbies are movies and dancing, hiking, swimming. The outdoor theme is apparent here. His career plans include joining the U.S. Army Corps of Engineers, and then also a civilian job at some point building bridges and buildings. Locally, Mr. Tanner Keene from Reiner, Virginia, nearby. His hobbies are golf and basketball, spending time with his family and church activities. And he's headed for a job with VDOT and a master's degree in the Vecellio Construction Engineering and Management program. And then on, we are happy to see pursuing and earning his PE as a construction engineer. Also just up the road, Jonathan Roach from Roanoke, Virginia. Again, an outdoor enthusiast, takes after, man of my own heart here. I like doing most all of these things, except the kayaking part. I learned quickly not to do that. His career plans are to become a superintendent of for a residential farm. Brian Maloney from Midlothian, Virginia. Again, both interested in sports, baseball and intramurals, as well as working with the Habitat for Humanity. His career plans include graduate school in structural or construction engineering, and on to be a project manager in the residential sector of our industry. Ms. Yasmin Shatahari is from Toronto, Canada, and Tehran, Iran. Her hobbies also involve the outdoor, skiing and hiking, yoga, and high-intensity training. Okay, we're out as old folks. Her career plans include obtaining a PhD in civil engineering. hopefully at Virginia Tech, and pursuing a career as a decision risk analyst. Is Maggie Wiltshire. She lives just down the road from where I do in Craig County, Virginia. I have to always tell this story. She lives in Newcastle. Craig County has 5,000 residents. We don't have a traffic signal, and we don't have a four-way stop in the entire county, so not much traffic, right? Her hobbies include reading, baking, and church activities, and she's headed to work with a general contractor. Dante Coronado comes to us from Lima, Peru. Hobbies including skateboarding, soccer, and guitar. And he's looking to work to improve infrastructure in developing countries. Mr. Robert Wallace from Reston, Virginia, again enjoys outdoor activities of biking, camping, and soccer, and is headed for a career in project management position with Alan Myers. Ladies and gentlemen, join me in recognizing these outstanding students. Okay. Thanks. Now to our guest of honor. Kristina Swallow earned her bachelor's degree in civil engineering from the University of Arizona and her master's degree in civil and environmental engineering from the University of Nevada, Las Vegas. Kristina has been with the City of Las Vegas since 2012 and leads a team of engineers responsible for delivering public works projects. She's responsible for negotiating design and construction contracts and coordinating with public and private sector stakeholders. If you've been to Las Vegas, you can appreciate how big a job that is. Prior to her current position, Kristina served as Senator Tom Udall's lead on transportation policy. She worked on the Federal Aviation Administration Reauthorization Bill and on the development and passage of the MAP 21 Surface Transportation Authorization Bill. Kristina has been very active, to say the least, with ASCE, the American Society of Civil Engineers, serving on various society-level committees, such as the Committees on Education and Diversity. She served as the Society's appointed governor on the Utility Engineering and Surveying Institute until her election as ASCE's 2018 president. For the first time in the history of ASCE, the past president, the sitting president, and the president-elect are all women. In addition to her professional activities, Kristina is active in her community. She served in the leadership roles with the Junior League of Las Vegas, Southern Nevada Bicycle Coalition, Engineers Without Borders, and serves on the advisory board to the University of Nevada, Las Vegas Department of Civil and Environmental Engineering and Construction. And ladies and gentlemen, please welcome ASCE President and the 2017 Vecellio Distinguished Lecturer, Kristina Swallow. Good. You all set?
Yeah, thank you. Hopefully I won't need my water, but like Chema, I'm struggling from a little bit of a cold myself these days, so I brought it just in case. Thank you all for having me here today. It's truly an honor and a privilege to be here as your Vecellio lecturer today. I want to talk to you a little bit about the future, about what our industry and profession is going to look like tomorrow. And I'm going to start with talking about today. So our profession is in demand. We know that. That's why many of us are here. And it's continuing to be in demand, and we actually project that moving forward, our profession is going to outpace many other professions in the demand and the need for us to help shape our communities. And that's exactly why, because everything we do builds our communities. Our communities, we are the foundation for our communities. And that's a fantastic thing for us as we're looking at the future. But it also is something we need to consider as we look at our industry and our profession and how we practice. And I want to talk first, as we look at this, about the state of our infrastructure in the United States. Many of you may know that every 4 years, since 1998, the American Society of Civil Engineers has released a report card on the condition of America's infrastructure. The most recent one was released in this year, in March. And unfortunately, we found that just like the last several, our grades have not come out of the level of a D. They stayed flat from 2013. In 2013, they had risen to a D+, and they remain at a D+. And we look at this, and when we develop the grades, there's 30 or so engineers that are involved on the committee that are looking at widely published data. They're talking to the technical experts. They're looking at the opportunities. They're looking at not just condition, which is something that we can see like on the roadways every day. If there's potholes, we see condition. We don't see condition when you're talking about our underground infrastructure. We don't necessarily see condition when we're talking about our electric grid, our electricity, our energy grid. Some of the condition we see. But we don't just look at condition. We look at capacity for today and tomorrow. We look at funding availability. We look at sustainability. We look at operations and maintenance. There's a total 8 criteria that go into developing these grades. And in this case, we fortunately saw that 7 of the grades have improved. 3 fell. And where we've seen grades improve, it's because we've seen investment and we've seen leadership and we've seen systemic planning, looking at the systems as a whole. And that's good news. Sometimes when we talk about this, I hear people ask, well, isn't this somewhat self-serving? Civil engineers, you're telling us the infrastructure is bad because you're going to help us build the infrastructure, right? I look at that 2 ways. Right now, our infrastructure is not serving America's needs. We're stuck in traffic. We're treating and pumping water that's not making it to the tap. We're treating water in our wastewater systems that never came from a tap. It just infiltrated. It was groundwater. And that's costing us money. But you can also look at, I like to talk about aviation. Aviation is a D. And there's some quality of life things there if you're a traveler. I travel all the time right now. And so when I go and I'm sitting at a gate, and I'm actually not sitting at a gate, I'm sitting up against a wall somewhere plugged into an outlet trying to charge my phone because there isn't a chair available for me, or the one that is has soda in it. That's a quality of life thing. But that's not really what what ASCE is concerned about when we're talking about aviation. We're talking about economic competitiveness and what that does to our communities. I live in Las Vegas. I think McCarran is a pretty good airport. We continue to build. I think we've been very forward thinking in terms of the capacity of that airport, so we're lucky. But in the next 3 years, it's estimated that 26 out of the nation's top 30 largest airports will experience Thanksgiving-level peak traffic once a week. So imagine if you're trying to get into Las Vegas, and if we're one of those airports, I don't think we are, but if we're one of those airports and you're trying to get into Las Vegas and we're at that Thanksgiving-level peak traffic and something goes wrong and you can't get there, that means you're not coming to my city. That means you're not making a donation. That's what I call gambling. That means you're not able to help our economy grow in Las Vegas. That hurts us every day. And it's not just Las Vegas. You can look at LAX. If LAX is on that list of airports, you can still get to LA. You can go to Burbank. You can go to Long Beach. You might even go to San Diego because it's not that far. But if you're going to Seattle and you can't get into SeaTac, what does that mean? So this is not just entirely about quality of life. Some of it's about economic competitiveness. Some of it's about jobs. There's some real life-saving aspects to this. If a bridge is out and the emergency vehicles have to take twice as long to get there, this is real stuff that we're talking about. It's not just about us today looking at what kind of jobs we can build in the future to build our industry or profession. It's about meeting the needs of our communities today. So ASCE looked at this and they said, well, we got a D+. Well, what does that mean? What will it take to get our infrastructure to a grade that you'd be okay going home with, or maybe even proud to go home with? What would it take to get us to a B? We would need to double our investment. In the next 10 years, we would need to spend an additional $2 trillion, of which $1 trillion is in the transportation area. And there's all the other areas that we looked at. I can tell you that as I've been talking about this over the years, I've been in various places, and they said that number is low. When I was in California and we were talking about dams, they said that number is low. Our number alone in California is that number. But the data is based on published available data. So this is what we have. It could be higher. It likely is higher. It's a challenge. As we talk about how do we develop this infrastructure, I had many meetings today. Chema kept me busy, and the questions were, how do we get there? And the good news is that people are taking notice. We've been talking about this for some time, and so we're starting to see elected leaders talk about infrastructure. It's a top talking point. During the election, the presidential election last fall, it was a top talking point. Both candidates, all 4 candidates, however many candidates, they were all talking about infrastructure and the need to invest. And we're seeing it at the state and local levels, where 50% of states have done something to increase their investment in transportation, whether it's increase in fuel tax, whether it's indexing. That's a good sign. We're starting to see people invest. And there's stories across the nation where it's not just in transportation, it's in water infrastructure, it's in flood control. We're starting to see that investment, but we have a long ways to go. And part of the challenge on this is, how do we communicate it? In fact, I had a student today, and they said, well, how do we get people talking about this? Our challenge is to make sure that our friends and our neighbors and our parents and our brothers and our sisters and everyone that we interact with understands that what we do is critical for our daily quality of life. It's critical for all of everything that we do. And that not investing ends up costing us more. It costs us, it's estimated that by 2025 it will cost us $3.9 trillion not investing. I can't think in trillions. Anybody here, can you think in trillions? I can't think in trillions. That's the equivalent of Germany's GDP. That's how much it will cost us if we fail to invest and to change the way we invest in our infrastructure. You can see some other data up there. $3,400 lost in household income annually. That's happening today. That's being stuck in traffic on the 66. That's repairing a flat tire because a pothole on the 66 bit ya. That happened to me when I lived out here in DC, working in Washington, DC. That's treating water that never makes it to your tap, or treating water that never came out of your tap. It costs us $3,400 each family every year, and in some cases it's more. One of the conversations we were having today, we were talking about Pennsylvania, and it's costing those families, those individuals, $6,000. And 2.5 million jobs lost. Again, these are numbers that are kind of outside of what we normally think about. So that's the equivalent to the number of residents in Houston. Jobs lost if we don't invest in our infrastructure. So how do we fix it? We invest. And I have a cute video here that talks about what it would cost and the fact that it actually saves us money if we invest a little bit more.
Our nation's infrastructure bill is overdue. And that's costing every American family more than $9 each day. This unseen tax is paid when you're stuck in traffic, when your house floods because a water main breaks, when your flight is delayed or canceled, when your groceries cost more, or when your power goes out. That all adds up to $3,400 a year. Can you imagine what $3,400 could buy your family each year? You could take a family vacation, start a college fund, buy a new computer and phone, or do a home renovation project. What if instead of losing money every day, you could invest just a little and end up way ahead? Would you spend $3 a day to save $3,400 a year? Seems simple, doesn't it? For just $3 a day per family, the United States could eliminate our infrastructure investment gap. Our inconveniences would be fewer, and we'd be better off economically, both individually and as a nation. Let's close the gap and invest in America's future. For more information, visit asce.org/failure to act.
I like this video because it provides us an entree when we go out and we talk to, like, if you're talking to your PTA, that's a really good way to talk about infrastructure. You show this video and you're like, what does that mean? What does it cost? And more when we're seeing infrastructure investment happening and when we're seeing ballot initiatives and voters are going to the ballot box and approving increased investment, they're doing it because we had conversations with them. Every day we talk about it because it impacts us every day. But I've been talking about America's infrastructure. I want to talk a little bit more about what the future has in store for us and a little more globally. So we're changing as a society. We've been changing for decades, probably centuries now. We are becoming increasingly an urban society, wherein today, over 50% of our global citizens live in cities. We have a population of about 7.6 billion, and we're growing at about 80 million a year. So by 2050, we will be over 9 billion people in the world. Over 70%, it's anticipated over 70% of those people will be living in cities. We've seen some of those changes in Las Vegas. My entire practicing career, except for the 3 I was in DC, has been in Las Vegas. And I moved to Las Vegas right when the economy said go. Turned it on, and they were checking pulses. Thank goodness I had one and a degree. So they hired me, and I got a job in Vegas. And we grew, when I moved to Vegas, I think our population was roughly 3/4 to a million in 1994. And today we're at 2.2 million-ish. And we thought that that was crazy growth. In the United States, we were talking about the fact that Vegas was one of the fastest growing cities in the United States. During that same time frame, cities in the greater globe, cities across the world were growing even faster than that. Shenzhen, China was about the same size as Vegas in 1990. It was less than a million. In 2014, 11 million people. Try to fathom building infrastructure for 11 million people in that time frame. We're not keeping up. We're not keeping up with the infrastructure needs of our communities. And as we continue to grow, that population growth is happening in the United States. We're definitely having population growth here, and it's definitely happening in the cities. But the majority of that additional 2 billion people will be in the developing nations across the world. And they lack access to energy. Roughly a third of our current population relies on solid fuels for cooking. Imagine what that does to a city when you don't have adequate access to energy. A third also lacks access to water, regular adequate supply of water, and access to sanitation. I had an employee come back from a conference the other day, and he was talking about what we're going to be looking at in the future. And he said, we're not going to be talking about all of the stuff that dominates whether or not you can get to work, the transportation system. We're going to be talking about whether or not you have access to food and access to water. And it's going to change the way we operate. And civil engineers have a huge role in addressing those challenges. We can meet those challenges. We can look at them, and we can make sure by developing new systems, by developing new processes, that we are able to meet the needs of the future. But we have to start thinking more systemically. We have to start thinking big picture, and we need to be engaged in the public policy realm. One of the things that I've recently learned is that in the United States, 50% of our water withdrawals go to supporting our energy systems. So when we're struggling with providing adequate supply of water, and we are in many areas of the country, we have water scarcity issues, we're using that water to supply energy or to water our fields. And so let's talk a little bit about this. Oftentimes, California is referred to as America's breadbasket, not because they grow a lot of wheat, but they're America's food basket. They grow our food, right? A significant amount of our food is grown, is produced in California. They're one of several states that rely on the Colorado River Basin for much of their water. The Colorado River Basin supplies significant 15% of the nation's food supply. 40 million people are relying on the Colorado River Basin for water. That's far beyond the supply of the Colorado River Basin. The network, the pact that was developed during a time of wet years. They didn't know it then, because we learn. That's one of the things we're learning. They didn't know it then. It was a time of wet. It was a time of surplus water, similar to maybe this past year in the West, but we know it now. And so how do we develop new systems, new processes to make sure that we can continue to meet the needs, not just of California, but of the entire West, of all of the states that rely on this water system, when we know that it's in scarce supply? And we're starting to see engineers step up and develop new ways to address that. The Carlsbad desal plant outside of San Diego is one of the largest in the Western Hemisphere. It just came online in the last couple of years, and it's showing that we can efficiently provide water and do new ways. Orange County is looking at having conversations about what it means to treat the water, pump it back into the ground, pull it back out. Unfortunately, it's been branded as toilet to tap. And so politically, it's a challenge. Somebody branded it that. I can tell you it probably wasn't a civil engineer that branded it that way, but it got branded. And so now they're struggling with trying to figure out how to better use the water, the scarce water that they have, how to better capture that and recycle it, bring it back so that we're not just sending it out to the oceans. So we have some challenges. In 2014, ASCE hosted a sustainability summit. And we looked at it, and Mark Woodson, then president, said, we as civil engineers have the opportunity to change the world. And they got together and they talked about what do we need to do and how do we move forward. And they found that we need to transform how we practice, how we look at our projects, how we talk about our projects and infrastructure as whole. And they developed some key priorities. And those are, we need to reinvent the process. We need to look at our projects from an outcomes basis. What is the project trying to do? Not the project specifically, but what is the goal of the project? And we need to think about it in a sustainable manner, not just that the project itself, the materials are sustainable, but that the project overall is sustainable. That we thought about not just the environmental impacts of it, but the economic and the social impacts of it. There are examples of projects that are very green environmentally, but maybe we're not economically sustainable, or maybe we're not socially sustainable. And we need to be thinking about these on a high-level basis. And there are examples of projects where we're starting to transform how we think. Where it used to be that managing storm water and flood control systems, we captured that flood control water, we captured those floods, and we diverted them as fast as we could out of the city and make sure that everybody was safe. But we're recognizing, again, water's in scarce supply. So how might we manage our water differently so that we can benefit from that water while still making it safe for us to get around our towns and not have floods? So we need to start looking at that. I use an example back home where we have a right turn lane, and the project came to us. I don't know how it came to us. I don't know if it came from crashes. I don't know if it came from queuing. I don't know if it came from the property owner. I don't know if it came from a resident or from a politician, but we have a right turn lane project. And so we're going to build a right turn lane. And that may be the best way to look at that project. But if we stepped back, might there be a different way? Is there a way that we could look at traffic signal optimization? Is there a way that we could develop better signage? Is there a way that we could manage the travel demand somehow? Provide more opportunities for people to bike or walk or use transit? What are the other ways that we could look at this project? And this one may still come out as the best solution, but we need to be thinking about our projects more systemically on a bigger picture level. And we need to develop new standards and protocols. So over time, we've gotten, as a profession, very comfortable operating within parameters. There's less risk there. Somebody has gone out and they've said, this is how to build a bridge, a building, a flood control system. And we've gotten very comfortable with that. But what we've learned is that the world around us is changing. Expectations are changing. And we need to be able to feel comfortable outside of those standards, and we need to be comfortable knowing how to operate if we need to step out, if those standards don't apply to our current project. How do we step out? When do we apply the standard? When do we say, this doesn't apply in this case? And if it doesn't apply in this case, how do we test to make sure that it's still safe? How do we make sure that when we go outside, when we become more flexible, that it's still going to meet the needs and the design standards? And we need to be able to talk about these. I was talking with some students today, and we were talking about risk. And our standards and designs and protocols and codes have all been set up to manage some risk at some level. Someone decided, I can use flood control as an example, someone decided that we design for 100-year storm events. And we've all agreed that that's what we design to. And then Hurricane Harvey happens. And the public says, why did this happen? Why weren't we protected? Well, Harvey wasn't a 100-year rain event. Harvey was I've heard varying numbers, but it was much more significant than a 100-year rain event. Could we have designed for Harvey? Yeah. What would it have cost us to design for that? Would the citizens have been willing to pay for that? We need to be willing to have the conversations with our residents, because they're starting to engage with us a lot more on infrastructure, and they're starting to have higher expectations, but they don't know what our decisions are being made off of. So we need to be able to have conversations regarding risk management, and let them help us make those decisions. Let them understand what the costs of those decisions are. So going back to our report card, we looked and we developed some solutions. It's not just investment. We're talking about needing investment, leadership and planning, and preparation for the future. On the investment side, I talked about it. We need to double our investment. We need to increase our investment from 2.5% to 3.5% of our GDP. I can tell you the developing nations that are struggling with meeting the needs of their increasing populations are outspending us. They have different challenges. They have different political environments. They are outspending us. But that's what we need to do if we want to have systems that are going to meet the needs not just of today, but of tomorrow. We need to look at making sure that when we do increase that investment comes from us most of the time in some sort of a rate or fee or tax, that it goes to where we said it was going to go. So far, the Highway Trust Fund has been very good about the trust piece. Money that goes into the Highway Trust Fund stays in the Highway Trust Fund on the federal level. I've heard that's not always the case at state levels. Sometimes there's an emergency need for an education investment, and so some of that money gets pushed off to the side. We need to make sure that when we increase investment from the residents and the citizens, that we make sure that money goes exactly where we told them that it goes. And we need to authorize and appropriate programs at the federal level. A lot of the programs that have been authorized, we've not put the money actually to. So we need to increase the investment. We need to step out there, be bold leaders. We don't just need elected leaders that are going to be willing to vote to increase investment. We need elected leaders who are going to go out and champion it, who are going to step out and not be the second person to vote or the third person, but the first. They need to be able to champion the bill. We found that when it comes to transportation investment, those elected leaders who support increase in investment actually return to office more frequently than those who don't. But we as civil engineers need to be part of that leadership discussion and leadership solution. We need to be having the conversations and being willing to step out there and talk to our neighbors, go to the Rotary, go to the PTA, talk about infrastructure, and talk about the fact that we need to increase our investment. I've talked to lots of people. In Las Vegas, we had a ballot initiative this last fall. It passed to index our gas tax. And I talked to engineers who weren't willing to pay for that. We need to come together and recognize the challenges that our industry faces and recognize that we're key to that solution, and we need to work together on that. We can't work against each other, otherwise we'll all get left behind. And we need to talk about the future. We need to look at what our systems, what are we building? Is it sustainable? Socially, economically, and environmentally. What happens 20 years from now when we need to decommission it? What happens to those resources? We need to be thinking on the big picture. We need to be thinking about resiliency and how our communities come back. We need to be learning from our projects. One of the things I had never even considered, but Houston is facing right now, is they're drying out. Their communities, the residents are recovering. The houses are in the state of repair that they're in. They don't know what the long-term impact is going to be to their roadway systems and their underground systems, because the water was wet for the ground was wet for so long. They're concerned that the pavement structure has been somehow compromised, and they're not going to see the impact of that for some time. Some of it maybe they'll see immediately, but some of it they won't see months, years. And are they going to be able to have the resources to address it when it finally materializes? Things that we're not thinking about. So we need to be thinking about these things, and resiliency, and developing, engaging differently. One of the things when you talk about water shortages and scarcity is you can link that to land use planning. As we become increasingly dense, we use less water because we're no longer watering lawns, swimming pools. What's our role in discussing land use planning? How should we start to have a conversation about whether or not the Walmart gets built, or where it gets built, or how much parking it needs? We need to engage in those conversations that we're not typically involved in. And to do that, we have to build the capacity of engineers. This is where I start talking about how we do that preparation for the future. And I had the privilege of working in Washington, D.C., and really having the opportunity to see how policies are developed, how they're shaped, how the elected leaders make decisions. And unfortunately, we're not engaged in those conversations. So a lot of times they're making those decisions based off of our friends and neighbors who are calling, and they're making decisions about whether or not to prioritize infrastructure because of the other phone calls they're receiving. So like I mentioned earlier, every single one of the candidates was talking about infrastructure being a priority when they were running for president. All of them were talking about how important it is that we invest in infrastructure, because investing in infrastructure creates jobs. It's good for the economy. They all know it. But then when they get to office, whether it's a presidential candidate or a senator or congressman, the people who are calling them are not calling them to say invest in infrastructure. They're calling them to tell them about how our schools are underfunded, or about how our health care isn't working for them. So then when it comes down to doing the work, they're prioritizing things other than infrastructure. And I've been asked, well, how does ASCE solve this problem? Well, ASCE is us. Whether you're a member or not, it's us as civil engineers. And the way we solve that problem is starting to engage and have these conversations and call. The bike people call. When it comes to transportation, I'm telling you, the bike people call. It's important to them, and so they call. And when I was in DC, I heard regularly about the condition of the bike lanes, or the lack of the bike lanes, or thanking us for making sure the bike lanes happened, or that there was funding. I did not hear, well, I heard from one engineer. The FAA bill lapsed for a month, for an entire month. And I heard from one engineer during that time frame about how we needed to get it back on track, and we needed to get it funded, and we needed to get it passed. I would be willing to bet there were a lot more than one engineer impacted by the fact that that bill lapsed. We need to engage, and we need to be comfortable. And I think sometimes, before I went to Washington, D.C., I was afraid. I don't know what I was afraid of, but I'm going to own it. I was afraid because I venture to guess a lot of us are afraid of the senators. What happens if the senator answers the phone? The senator never answers the phone. And even if you get beyond the front desk, you're talking to someone who doesn't know anything about infrastructure. Some of them have been there for a while and they understand the funding mechanisms, and they do understand it. But really, we're the experts. There's nothing for us to be afraid of. Even if it's not in your specific practice area, we're the experts. We need to get comfortable with calling and saying, hey, this is a problem. Do you know that I sat on, I'm sorry, I know we're not up in the DC Metro, but do you know that I sat on the 66 today for an hour and a half to go 10 miles? What could I have been doing differently? The bicyclist will say, you know, I couldn't ride my bike to wherever. But we, as civil engineers and experts, aren't calling and saying, hey, do you know, I had to boil water last night because of that water main break. Or that water main break on UCLA's campus in 2014, that cost $13 million in damages. That's a heck of a lot more than what it probably would have cost to fix the line in the first place. But we're not calling and saying, you need to invest in infrastructure. We need to find a solution. So we need to step up, which is what this is about. This is a picture from one of the fly-ins. ASCE has a fly-in every March. And a whole bunch of us go, and we talk about him. And sometimes we get to talk to the actual elected leaders, and sometimes we don't. But it goes far beyond this. We need to talk to them throughout all times of the years. We need to talk to them when they're back home. We need to talk to our friends and our neighbors and talk about what this means. And we need to get involved because really the solutions, the answers, they're political, right? If 50% of the US water is being used for energy, raising water rates is going to be hugely political because it's going to have an impact on energy, right? And vice versa. Water, a significant cost of producing and delivering water to the tap is energy. These are political conversations, and we as engineers need to not just look at it as our role as designing the solution. We need to get involved and get engaged in the higher level policy systemic discussions so that we can help develop solutions to meet the needs of our growing populations moving forward. And to do that, we're going to need more formal education. So you guys, I don't know that you can fully read this, but in 1995, ASCE 7, which is the code and the standard that really drives building loads, design loads for buildings and structures. It's not my practice area, so that's why I stumble on that. But you can see it was only, 236 pages. The most recent iteration, well, actually that was 2010, was 658 pages. I can't even tell you what ASCE 716, which was just released in the last year, is. The amount of knowledge that we need to know is far greater than what I needed to know when I graduated. We're learning. Every time there's a hurricane, every time there's an earthquake, every time there's a heavy, massive snow, we're learning about how buildings, structures, how they react, how they withstand the forces. And so we're developing new information, and we're developing new codes and standards. Now some of this, maybe we need to, some of it we may need to talk about, like, well, is it too much? Do we need to start looking at being more performance-based than prescriptive? There's conversations about that going on, but we still need to know more. I talk about my education, and I do it in context of this graph. So this graph shows that since 1900 to 2010, civil engineering education has remained flat, while everybody else has moved and jockeyed around us and increased beyond us. And the challenge with this graph is that it shows that civil engineering education has remained flat. It hasn't. Almost a full year of education has been cut from the program since I graduated. And yet, like I said, we need to know more because We're learning more. We need to know more because we have to engage differently with our elected leaders. At one point in time, we were those people that were saying, I want to get across the river. I want to get across the bay. I'm going to build a bridge. And we didn't have codes and standards to build the Golden Gate or the Brooklyn Bridge, but we figured it out. And we figured out how to communicate that that investment was important to our communities because it was going to help build their economies. It was going to help meet a need of their citizens. We need to get back there. And we need to start talking about, in our programs, risk management, resiliency, sustainability. I had a student ask me today, if we're talking about public policy, do we need to have engineering law, engineering policy? They came up with a great name for the class. But we do. We need to start having conversations about how do we engage differently? How do we engage with our stakeholders differently? And I know most of you are students, sorry. But I also know that a number of you, if not most of you, are already thinking about the fact that at some point further down in your careers, you're going to get that master's degree. You're going, whether it's immediately through the 5-year program, or whether it's at another university because of a practice area that you're interested in, or whether you're waiting to get into practice to make sure that your specialty area is what you really want to do, and then have them pay for it. And I know a number of you are already thinking about that. And that's important, because regardless of whether or not it's a requirement, that additional education will set you apart. It will set you up for further advancement in your career, and it will help you achieve these better conversations and help us achieve the aims of our role as civil engineers. You know, civil engineers, our vision as ASCE is civil engineers are global leaders building a better quality of life. And in order to do that, we have to engage differently. So ASCE didn't just come up with this graph before and say, oh, our education is flat, all these things have happened. There's actually a study, the Engineer of 2020, by the NAE, and they looked at it and they found that it's just not fitting anymore. And there's a lot of driving reasons for that. Some of it is there's more education required, some of it is state legislatures, but we need to do more. And we need to do more not just because we're struggling here in the United States, but we're struggling as a globe, and our population is growing, and the needs of tomorrow we haven't yet figured out. And even here, I was at the VTTI earlier, and they're talking about all the cool things. Like I was geeking out. Chema got me totally exhausted, like all these great conversations. You guys have exercised my brains, and then he takes me to VTTI, and they're telling me about all the fabulous research they're doing in autonomous vehicles. And students ask me, well, what about autonomous vehicles, and what happens to the labor force for all the people who are driving vehicles today? And then somebody else, and then we had the conversation about, well, what happens when they get in mixed traffic? You know, change is coming. It's coming here already, and we need to be prepared to have the conversations around to support it. Because ultimately, we can meet the needs. As Mark Woodson says, we can change the world. We just need to prepare for it today and tomorrow. Thank you.
So we have a few minutes for questions. We'd ask that you come to one of the microphones up front to ask your questions. We're recording this, and that way also everyone can hear your question.
Yeah.
Okay.
I think that,
okay.
yeah.
Can you tell us what you feel the ethical obligations are for civil engineers with potentially catastrophic impacts due to climate change, particularly as it relates to our continued use of fossil fuels?
Whew, that's a big question. So let me try to restate it. So what are the ethical obligations of civil engineers regarding potential catastrophic impacts in the future of climate change as they may relate to fossil fuel usage. And I say may because there's climate change. And some of it's driven by fossil fuel usage, some of it, there's lots of things that feed into that. So what are the ethical obligations? We need to be involved and engage in those conversations. We can't just say, sea level rose, right? We can't just say that and be like, oh, I didn't know. We need to be engaged in those conversations, and and that's part of where we have to talk about, we need to be comfortable talking with the public and saying, hey, look, the data shows that this is going to happen. And to prepare for that and to mitigate against that, to design for that, it's going to cost this. And it might be, there's different kinds of costs, right? There's money costs, there's resources costs, there's quality of life costs. We need to be able to have those conversations. Sea level rise is a huge thing if you're on a coastal community. Look at what's going on in Florida. Many of those people choose to still live on the coast. On all of Texas, they live on the coast. They're making those choices. For them, one of the costs of addressing climate change might be not having that beachfront property, and they're willing to pay that cost. They want to stay. But we need to make sure that we're involved and engaged in those conversations and talking to them about it. You talk about climate change. I have a very good example. It's not climate change, but it's seismicity. There's a young engineer in Oregon who was part of Oregon Public Broadcasting's program. They did a program, it's called Unprepared, and it's talking about the potential catastrophic impacts of a major earthquake on the Cascadia Fault. The engineers in Oregon have looked at what the impacts could be of that fault, of an event on that fault. They've determined what needs to happen to mitigate against that and what needs to go into design standards to mitigate against it. They've talked to the communities, and they've given them the options. So in essence, they're doing their job. The challenge comes when the community says, thank you very much for your information, we're going this way. And unfortunately, sometimes when the community says that, it's a select few members of the community. And it's based on nobody's coming at this with ill will. They're coming at it with best of intentions, given the funding and the constraints that they have. But we need to be able to have these conversations. And in Oregon, they were successful in developing and creating a statewide resiliency officer role. And that's starting to become something that's more common, and more people are talking about doing that to help engage in these conversations. The young woman I'm talking about, she is regularly out talking to Rotaries and PTAs and other community junior leagues and Boy Scout troops about what a seismic event would be, what an earthquake might be on the Cascadia Fault and the impacts of that. So they're doing their job. That's hard for us to do, because I don't know that her company's always paying her to do that. Sometimes that means that we're stepping out and we're choosing to use our free time to be leaders in that which we're experts in. So we do have a responsibility.
Another few minutes. The class doesn't get out early. So.
They're all afraid of that. With that question, they're like, whoa. Yeah, you have to go to a mic because they're recording it.
Yeah, you need to.
Okay, I have a problem with the funding of the infrastructure that everybody talks about, but nobody does anything about. I was talking with the Commissioner of VDOT 2 weeks ago, and I said, why, and for 20 years I've been saying this and nobody does it, it's all what it's for. Why can they not add 10 cents a gallon onto the gas? Nobody would notice it. You put it up 2 cents this month, 2 cents next month, 2 cents. Everybody would just think it's a fluctuation. But as soon as I said it, he went absolutely pale and said, oh, they would never do that because nobody wants to put a tax on anything.
Yeah.
because they wouldn't be voted in next time. Somebody just needs the guts to do this. And I mean, I'm happy to do it myself.
Awesome. Is she going to run, Mike? Campaign manager? Yeah.
The big problem with that, I mean, it could solve so many problems so quickly.
You're 100% right.
And the point is, over the 20 years that I've been on it, it's just talk. Nobody will do anything.
And they're afraid.
Yeah.
And they're afraid because,
So we'll never get anywhere.
but we are, and actually in that specific area, maybe not in Virginia, but we are making headway, and we're seeing that people are, that electeds are choosing to allow ballot measures to go forward, or making the decision straight out to increase the fuel tax in many states. I think over 50% of the states in the last 5 years.
Vote on it. Why can't somebody just write 10 cents a gallon and...
If only.
Nobody would notice it for years. There's such a pile of paper on everybody's desk, it would go through.
If only, but then we start getting into ethical implications. So, yeah, so it has to go to votes, but we're finding that people are doing it, and they're being successful at doing it. And when they choose to do it, those elected leaders who take the risk actually get returned to office more often than those who don't. So,
You should tell them.
happy to get you some information if you want to tell them.
You seem to be very community focused and empathize with the people you design for. Can you speak to the students of how you became this way and how it's important for them to not only empathize with the people they're designing for, but be a part of the communities they're designing for?
Oh, geez, how did I get there? I don't know. So you saw a lot of really awkward pictures of me up there earlier, and I think it's going to be my parents, right? So I grew up being very engaged in the community, whether it was, a cheerleader, maybe not so much, but being with 4-H. Anybody 4-H? FFA? What, hands, heart, health, head? Yeah. So, I mean, that's one of the things with, with being involved in the community growing up. Like that was, and it's all to help the community. I can't tell you the whole pledge, but, I somehow Boy Scouts be prepared, whatever. But it's the best. I don't know the best solution, right? I don't know. None of us, not a single one of us in this room knows the best solution. We all know several solutions, and I can go to a community and I can say this is the solution. But until I know what they're living and they're experiencing and how they're using, I'm not necessarily going to have the best solution. I can tell you that I went through a leadership program, and we did an exercise. We did several exercises that were intended to show us that not everybody has our same experiences at all. And I'm like thinking about them, and it makes me tear up because it was very eye-opening and profound for all of those of us who participated in it. And it really helped send that message. And the people that were in it, I mean, we weren't all engineers. We all did all kinds of different things. But it really emphasized the fact that we can't just come in and say, here's the answer. We have to, for the best projects and the best outcomes, we have to be talking to the members of our communities. We have to not just talk to them. We have to go with the 2 ears, 1 mouth. We need to listen. And in doing that, we're going to develop the best solutions. Now, fixing that water line or that wastewater line that has exfiltration or infiltration, depending on which one you're talking about, we can come up with the best solution on that, right? But when you're talking about how our cities are planned, how our transportation networks are built, how we're actually providing water and energy, we need to be listening to our communities and understanding the challenges that they face on a daily basis.
Ladies and gentlemen, join me in thanking President Swallow. I think the students have something for you. Just a second.
Yeah.
Nicely done.
Thank you. Are they going to dance?
I can't dance, so you're on your own. Yeah, I can't sing, I can't dance.
Well, one of the ROTC guys is a dancer.
They're dancers and
Yeah.
singers, okay.
Sorry, you guys get to hear our conversation up here.
Yeah, they can.
Oh, okay.
The best one for the last, which is coming, but here are some of those.
So I need to open them?
Yes, she does. I'll turn it over.
Oh, a hokey hard hat. I have a baseball cap, but I don't have a hokey hard hat. And oh, I think I might have to wear this tomorrow on the plane, right? Right? It's homecoming, so I might have to wear that tomorrow. Everybody will be like, why are you going home? And, oh, this one's heavy. This one's heavy. Ooh. Awesome, because they kept me so busy today, I haven't had a chance to see any of the campus. Although Chema has done a really good job of driving me around and pointing out buildings, but this, thank you.
So this here has Virginia Tech crest in the front, and in the back it reads, Miss Kristina L. 2017 Vecellio Distinguished Lecturer.
Oh, that is amazing. I got it. Got it, yeah. See?